Okay, hello there guys, welcome back to another LibGDX video game tutorial. So in the previous video we improved the collision detection and increased its speed so that it runs faster on mobile devices. However, I had a problem when I decided to use pre-rendered values. Anyway, so it turned out that I was accessing the files the wrong way. It seems that there's a difference between the desktop use and the Android use. Anyway, so I'm gonna show you what did I do here in the code. So first in the assets folder, uh, here I added uh, this directory cd for collision detection, and this directory will contain all the files needed for each case uh, of collision detection, meaning the sprite name followed by the angle of rotation, if that uh, if that makes sense. Okay, and basically I render everything here on the desktop, and on mobile devices it will only load things, which is way much faster than rendering and extracting the data. Okay, so let me show you what did I do here in the code. So all I had to do is change this function, how it works in the sprite class, generate collision byte array for sprite here. Okay, so first I'm using this function. I'm getting a file handle, GDX files internal. Okay, and I am using this cd, okay, for collision detection. This is the directory, this is this directory. Okay, and I added to sprites cd file name, collision detection file name. Each sprite will hold the file name, a unique file name here. Okay, it will be the same for the sprites that have the same type. That makes sense. And then I'm getting the value and converting this to string. Okay, I'm converting the angle and adding .cd for collision detection. So if the file exists, this means I already pre-rendered everything, so I don't have to do extra work. All I have to do is read the bytes, and this read bytes will return a one-dimensional byte array. So what I am doing is creating a two-dimensional byte array and then looping on that, so I am converting the one dimension to two-dimension array. Okay, just reordering things, that's it. Okay, so that's it. Uh, Otherwise, if the, let's say, the file doesn't exist, which means that I am running the game on the desktop itself, this means I want the game to generate these files so that later on when I build for Android, these files will be included. Okay, so what is happening is that I am generating the service, rendering everything, and then generating the byte array. Okay, the two-dimensional byte array, if that makes sense. Anyway, and then I am creating a local file. Okay, so pay attention to this. Here, this is internal. Okay, when you are working on desktop or Android, this is internal, and if you are working on desktop, use local. Okay, if you change this to internal, start giving you problems and stuff. I'm not sure why, but the implementation is not exact, as I can see. Anyway, so basically I am writing this file and writing the first row of bytes, because this is a two-dimensional array of bytes. It's like the first element contains 128 one-dimensional byte array. So I am writing these and I am setting append to false, meaning that overwrite everything. And for later rows starting from 1, because I already wrote 0, just append these. and that's it. It's very straightforward. So what do you have to change? Basically, let me show you this. If we go up here, where is that? Where is that? Where is that? Yeah, this is the variable I added. CD file name is here. So all I have to do is basically go, for example, to blue enemy. This is the constructor, and I am saying collision detection file name equals blue enemy. So the file name will be blue enemy. In case of enemy shot, collision file name equal enemy shot, and green enemy the same, and so on. So I assume you get the idea. Uh, so I will show you the files being generated here. So let me go to, where is that, Android. Let's go to assets here. Okay, so these are the files, and this is the directory. If I open this, you'll find a huge number of files. Don't worry about these. The generation is all, as you can see, all automated. But take a look at this. This is a player spaceship, and there is a 0. Okay, player spaceship, there is a 1, and so on. So this means that this is the collision detection information for the player spaceship at angle 1.0. Okay, and so on. Basically, I'm using the angle as integer value. So yeah, actually I could make this a little bit you know, more alphabetic in nature. So maybe I would change this a little bit, if that makes sense. So actually I'm going to change this. So I will select all these files and remove them. Okay, and these files are not that big. Actually, all the collision information, I think it amounts to 32 megabytes uncompressed. If you compress these, it will be so small. Okay, uh, anyway, so let's go back to the game itself. I want to go to sprite and change a few things here. Where is that? Yeah, this is it. So now the file name, I'm gonna change this one. So I will create this function, string file name equals cd slash plus this dot cd file name. Okay, now I need to get the angle. So now I will say int GMP angle equal angle. Okay, so I am converting this to integer. Now if GMP angle is smaller than 10, if it is smaller than 10, in that case I will just say file name equals file name plus 00 plus integer dot toString, and I'm gonna pass the angle. There you go. Okay, and the reason for that is that I want the digits to be, you know, I will use 3 digits. Now else if DMP angle is smaller than 100, so we have, you know, something like this. Since this number will be 2 digits, so we just need to add a single 0, and finally else we just say, just keeping the same style. Don't have to use these brackets, but you know, sometimes I'm stupid this way. Anyway, so we add these. That's fine. And finally, I'll just say file name equals file name. Add to that dot cd for collision detection, and you could change this to anything you want, for example dot bin, whatever, it doesn't matter. So here I will use file name, very straightforward, and in this part I will also use file name. It's very straightforward. So now I'm gonna run the game, and it is going to run. It will gonna hang a little. It's going to hang a little because it will be trying to render all the collision cases. So I'll open this directory here just to show you what's going on. So it is building now, compiling. Give it a second, please. Okay, and as you can see, now the game is generating the files, and this is much more organized. So you have player spaceship 000, 001, 002. These are the angles, and if we continue, okay, you can see now we will reach 359 soon. Okay, that's good. Okay, and as soon as this one finishes, we get the introductory screen. We click here so that the others get generated as well. So here, the three-headed spaceship, as you can see, it's being generated. Okay, as you can see, 170, 180, 200. Okay, that's fine. Continuing that trend until the game appears. Okay, so now we got these. Now we use the player shot. Okay, so this one's also working. And we need to do this once. It will only work one. We will need it only once for rendering, and later on, after all these surprises are generated, we don't need to change anything at all, and we will run in a second after all these get generated, and you will see there is a huge difference in speed. Okay, if that makes sense to you guys. Okay, so okay, so this is the shot. There is also the green enemy, and let me share this. Okay, so it's working. Okay, that's fine. Anyway, we just want the other waves to come so that we get all the enemies. Okay. Come on, faster. Okay, so now there's the second wave. Okay. I assume maybe I should have created a special stage where I add all the enemies at once. That would be much better. So now a new enemy is being, collision formation, the green enemy here, it's being generated. Okay, faster. And sorry. And the blue enemy, and I assume the enemy shot also needs to be rendered here. Just give it a second, please. Okay, that's fine. So now this one's working, and the only thing that we don't have is the blue enemy shots. So when that enemy appears, it will attack us, and the enemy shots will appear as well. Okay, so now the basic problem you might be wondering, well, maybe you you pre-render things, but this is taking too long. Well, I will show you now what happens when we run the game again. It will be extremely fast. Uh, you will notice very little delays, one time only, and then the delays will disappear, if that makes sense. Okay. Okay, so now we have this, it's all done. So let me show you now what happens when we run the game again. So we press run, and okay, so fast, and we click here, so fast. When we shoot, it is running extremely fast. Okay, it's running extremely fast here. So we got rid of the delay. So pre-rendering is great. So we pre-rendered all the collision maps for our surprise on the desktop, and we are carrying these over into Android. Okay, so um, I will run this on the emulator just to show you that it is working actually. So I won't connect my device. I tested that on my device. It's working extremely fast, so we have no problem. Uh, so I'm gonna say give it an OK here. Yeah, just give it a second. So basically, this solves a huge problem. So we have now accurate collision detection, and not only accurate, but also very fast. Now, the only downside to this is that when you add more sprites or modify existing ones, you might need to recreate the sprites again, if that makes sense. So this might be the only problem we have right now. Okay, uh, but when you are producing or publishing the game, you already have all of these completed, so you don't have to worry about it. It's just important that you remember uh, you only added new surprise, so you need to solve their problem. That's it. Okay. Okay, let this emulator start and see what it is going to do. Okay, so now I'm gonna start the game, and okay, so these are the directions. Okay, did you notice the delay? It was almost half a second, but it happens once and that's it. Okay, if that makes sense. So okay, so here this is the wheel. Okay, that's fine, and yeah, so it is working. The collision detection is working perfectly fine. No problem. Yeah, so since we have done that, let me stop this and just give it a power off. Yeah, so since we have done that, and we have no further problems with collision detection, we can now go back and focus on the game enemies and bosses and stuff like that. So hopefully in the next video we continue our work with you know, the bosses and the enemies, and see what can we do. So that will be all for today. Thank you for watching, and have a nice day. Bye bye.